Assalamualaikum warahmatullahi wabarakatuh. Our group will present the topic of emulsion polymerization. My name is Nur Ain Zulaika binti Zamri and I will present the introduction and the product produced by emulsion polymerization. The introduction. The origin of emulsion polymerization starts with an attempt by man to mimic the production of natural rubber latex by the rubber tree Hevia brasiliensis, have resulted in the development of a process for performing free radical polymerization. It was developed during World War II because of the need to replace the latex of natural rubber. Emulsion polymerization is a unique process that involves emulsification of hydrophobic monomers with an oil-in-water emulsifier and then initiating the reaction with either a water-soluble or an oil-soluble monomer. To disperse hydrophobic monomer across an aqueous solution, it must be in the presence of a stabilizer, which can be ionic, non-ionic, or protective colloid. Typical polymerization monomers involve vinyl monomers of the structure of CH2 double bond CH.
Hi, my name is Wan Adlina binti Wan Sharifuzila. Right now, I'm going to explain about the concept and the process of emulsion polymerization. In general, an emulsion polymerization system consists of a depositing medium, monomer, emulsifier, initiator, and if necessary, modifier. The monomer are only slightly soluble in water. They form droplets that are suspended and stabilized by the emulsifier. That is, the emulsifier molecules associate and form micelles that surround small amount of monomer. Common emulsifiers are anionic and non-ionic surfactant. A combination of both anionic and non-ionic surfactant will often improve the stability of the dispersed droplet. The first hypothesis of the mechanism of emulsion polymerization was proposed by Harkins II. The process can be divided in 3 stages. To begin with, which is stage 1, monomers in active micelles are consumed and replenished through chain growth and diffusion of monomer from the monomer droplets. The particle number and the reaction rate increase with time. Next, stage 2. All surfactant in the system has been absorbed or all initiator molecules have been used up by the polymer particles. Both the number of polymer particles and the rate of polymerization is constant. And lastly, stage 3, the reaction mixture consists solely of monomer swollen polymer particle with dissolved monomers. Both the monomer concentration and the reaction rate steadily decrease with time and stops when monomer has been used up.
Assalamualaikum and hello everyone. My name is Nurul Fatim Azli. I will present about the advantage and disadvantage of emulsion polymerization. First, the advantage is the emulsion polymerization is rapid polymerization than bulk or solution polymerization at the same temperature. Next, the heat control is easy and easy agitation. So, heat is relatively easy to remove from the reactor with water as the continuous phase and suitable for the production of soft and sticky polymers. It also doesn't have a problem related to chain transfer or heat transfer. Next, the heat dissipation and viscosity control are much less problematic than in bulk polymerization. Viscosity of polymer emulsion is much lower than that of straight polymer in melt phase. Stirring is also easy since solution polymerization generates a low viscosity mixture. Next, a very high molecular weight polymer is obtained. The average molecular weight is usually much higher than at the same polymerization rate in bulk or solution polymerization. The last one, the final product can easily be removed from the reactor due to lower viscosity and it can be washed out with water. Continued phase, whereas water acts as a heat sinks and allow temperature to be much better controlled and avoiding dangerous overheating. Alright, in this slide we will discuss about the disadvantage of emulsion polymerization. First, emulsion polymerization is a less end product than slower bulk polymerization. So, polymer may require additional cleanup and purification. Next, the polymer can easily become contaminated with traces of the emulsifier. Difficult to eliminate entrenched coagulant, emulsifier, surfactant, and etc. And is often require rapid agitation. The resin produced frequently become contaminated with the emulsifier, almost inevitably leading to poor clarity. and other undesirable properties. Next, need a heavy technology investment to recover emulsion polymer in solid form, where heavy technology investment is costly. Last, the high water use in emulsion polymerization result in lower yield per reactor volume. This can generate very large amount of water. It's not necessarily a disadvantage, but it does have been adequately treated and disposed of.
Hi, my name is Shazwan binti Slamat. So today I will explain about ingredient and reaction related to emulsion polymerization. Okay, the first ingredient needed is monomer. Typical monomers are those that undergo radical polymerization, are liquid or gases at reaction condition and poorly soluble in water. If monomer solubility is too high, particle formation not occur and the reaction kinetics reduce to that of solution polymerization. Okay, next, initiators. Both thermal and redox generation of free radicals have been used in emulsion polymerization. Although organic peroxide and hydroperoxides are used in emulsion polymerization, initiators are usually water soluble and partition into the water phase. Okay, next, surfactants or emulsifier. The surfactant must enable a fast rate of polymerization, minimize coagulum of fouling in the reactor and other process equipment. Anionic, non-ionic and cationic surfactants have been used, although anionic surfactants are by far most prevalent. Surfactants with low critical micelles concentration are favored. The polymerization rate shows a dramatic increase when the surfactants level is above the CMC. Minimization of the surfactants is preferred for economy reasons, and the adverse effect of the surfactants on the physical properties of the resulting polymer. Mixture of surfactants are often used. For example, surfactant commonly used in polymerization include fatty acid, sodium lauryl sulfate, and alpha olefin sulfonate. Okay, next, non-surfactant stabilizer. Some grades of poly and other water-soluble polymer can promote emulsion polymerization even though they do not typically form micelles and do not act as surfactants. Dispersion prepared with such stabilizers typically exhibit excellent colloidal stability. However, they often result in products that are very water sensitive due to the presence of the water-soluble polymer. And lastly are the ingredient, which is chain transfer agent, buffering agents, and inner salts. Preservatives are added to product salts as liquid dispersion to retard bacterial growth. These are usually added after polymerization. Okay, next we move to the steps in emulsion polymerization, which is the first one is water, soluble in water, polymer born in water. Okay, next, growing polymer particles, monomer inside the micelles decrease. Monomer swollen micelles, polymer moves to the micelles, and then it will uncreated monomers in other micelles, and in droplets diffuse through water to the growing particles. And lastly, reaction terminates when second radical get in reaction, start again for the second chain when third particles get in. Okay, next we move to the next slide, which is mechanism. There have two possible scenarios, which is the first one is termination plus growth, and the second one is homogeneous nucleation. Okay, the surfactants molecules surround small amounts of monomer molecules creating micelles. There are also large droplets of monomer that are stabilized by small amounts of surfactant. Initiators form free radicals in the water, where they may find a few monomers to react with. In any case, the radical diffuse into the micelles where they find a lot of monomer but no other growing change to cause termination. The growing change is then protected from termination until a second radical diffuse into the micelles. This is why the MW can be so high in emulsion polymerization without slowing the rate of reaction. Okay, lastly, from the reaction, which is monomer plus initiator plus surfactant, it will become polymer. The monomer is dispersed in a large amount of water and then emulsified by the addition of soap. The initiator is added. The whole content is taken in a flask and heated at a constant temperature with vigorous agitation in a thermostat with nitrogen atmosphere. After 4 to 6 hours, the pure polymer can be isolated from the emulsion by adding of the emulsifier, like 3% solution of RAS1133D, which is aluminium sulfate.
The example of product produced by the emulsion polymerization. The wide range of products, which include synthetic rubbers, toughened plastic, paints, adhesive, paper coatings, floor polish, sealants, cement and concrete additive, and nonwoven tissues. More sophisticated applications are also found in cosmetic, biomaterial, and high-tech products.